Close your eyes for a moment. Imagine a silence so complete it feels heavy. No wind, no echoes, no life. This is what we are told space should be like. And yet, something breaks that silence. A deep, rising hum, a sharp metallic screech, a rhythmic pulse almost like a heartbeat. These are not movie sound effects. They are not added for drama. They are not fictional. They are real signals, captured by instruments drifting far beyond Earth, recorded by machines built to listen where humans cannot survive. When scientists first converted these signals into sound, many felt an unexpected chill because space was never supposed to sound like this. What if these sounds from space are not normal? To understand why this question matters, we must start with a basic truth. Space is a vacuum. There is no air, no medium to carry sound waves. So how can space make any sound at all? The answer lies in translation. Space produces electromagnetic waves, plasma vibrations, and radio signals. These are invisible, silent to human ears. But spacecraft can detect them. And when scientists convert those signals into frequencies we can hear, space suddenly has a voice. And that voice can be disturbing. In 1977, humanity launched 2 machines on a one-way journey into the unknown. Voyager 1 and Voyager 2 were designed to explore the outer planets, then continue drifting into interstellar space. They carried instruments to measure plasma waves, tiny vibrations caused by charged particles moving through magnetic fields. For years, the data seemed ordinary. Then the signals changed. As Voyager moved farther from the Sun, the instruments began detecting intense oscillations. When converted into sound, the result was eerie, a long, hollow howl, a sound that slowly rose in pitch, a noise that felt unnatural. This wasn't chaos. It had structure, it followed patterns, and it came from the very edge of our solar system. Our Sun surrounds the planets with a vast magnetic bubble known as the heliosphere. This bubble shields Earth from much of the dangerous radiation pouring in from deep space. At the edge of this bubble lies a boundary called the heliopause, a frontier where the Sun's influence ends and interstellar space begins. When Voyager crossed this boundary, the sound changed again. Interstellar particles pressed inward, magnetic fields twisted and collided, plasma densities increased. The converted audio became sharper, stronger, more unsettling. Scientists described it as strange, haunting, and deeply uncomfortable. Not violent, not explosive, just wrong. But Voyager's recordings are only part of the story. In 1997, something unexpected was detected much closer to home. Underwater microphones operated by NOAA picked up a sound so powerful it echoed across the entire Pacific Ocean. They called it the bloop. The signal was incredibly low frequency, louder than any known animal, stronger than earthquakes. For a brief moment, even scientists considered the impossible, an unknown life form, something massive, something hidden. Years later, the sound was traced to ice fracturing in Antarctica, but the fear remained because the universe produces similar low-frequency signals, immense, mysterious, difficult to explain. And then came something even more disturbing: fast radio bursts. FRBs are among the most powerful events ever recorded. They last only milliseconds, but in that instant, they can release more energy than the Sun produces in days. They come from distant galaxies, billions of light years away. Some repeat, some vanish forever after a single burst. Their origins are still debated: magnetars with collapsing magnetic fields, black holes interacting with surrounding matter. Extreme cosmic events, unlike anything on Earth, all natural explanations, all terrifying. When these signals are converted into sound, they resemble sudden cosmic cracks, like space itself snapping under pressure. And this leads to a darker thought. What if these sounds are not just background noise? What if they are symptoms? The universe is not calm. It is active, violent, constantly reshaping itself. Stars are born in chaos. They die in silence and radiation. Magnetic fields stretch, twist, and tear through space. These sounds may be the universe releasing energy, or they may be warnings. If the heliosphere weakens, more radiation reaches Earth. If magnetic storms intensify, satellites fail, communication systems break down, power grids become vulnerable. Not sudden destruction, but slow exposure. A reminder that Earth survives because of balance. And space does not care about balance. On Earth, sound warns us. A rumble before an earthquake. A crack before ice breaks. A siren before disaster. We evolved to fear certain sounds for a reason. In space, we do not listen with ears. We listen with machines. And those machines are telling us something important. The universe is not silent, it is not peaceful, and it is not designed for us. If these space signals increase in intensity, the effects would come step by step. First, satellite interference, navigation errors, communication disruptions, then increased radiation exposure, riskier space missions, limits on deep space travel. Over time, subtle changes to Earth's atmosphere, small shifts with global consequences. Not an apocalypse, but vulnerability. These sounds from space are not voices, not messages, not signs of intelligence. They are something more unsettling. They are evidence that the universe is alive with forces beyond our control, forces older than Earth, forces that shaped galaxies long before humans existed. For the first time in history, we can hear them. And the more we listen, the more we realize something uncomfortable. Space was never silent. So the question is no longer why space sounds scary. The real question is this: what happens as we listen deeper? Because if these are only the surface noises of the universe, what lies beneath, in the regions we have not reached yet? And what if the scariest sound in space is the one we haven't heard yet?